Hello, my name is Marco Hampel, and I made a parallax oscillation mapping renderer.
So first off, I guess just to demonstrate what we have here, this is a basic scene graph which implements several quads and a sphere displaying the surface of the moon, surface of several rocks, a brick wall, and the Earth on a sphere up above. These are textured, and if I hit the button B, I can toggle on and off the normal map for this texture. Now, as you can see here, the surface of these quads and the sphere look very flat. Um, and that's because we're looking at it from a very sort of low angle, which, as we know with normal maps, sort of reduces a lot of the benefits that normal maps bring and remove the realistic three-dimensional um, benefits that normal maps provide. And so this is where we bring in something like parallax. What is parallax? Well, parallax is a rendering technique, effectively a shader, which takes in the position of the camera, shoots a ray towards the surface, and then uses a height map to determine where exactly a ray from the camera would intersect it. Then it offsets the texture coordinates of the diffuse shader of the diffuse textures and the normal maps to skew the entire surface to look more 3D, to create this 3D effect. And it does so quite well. As you see here, if I hit H, I can increase the magnitude of the height maps. So initially it's flat, and now if I start hitting H, it increases it. And as you can see here, now this entire surface has gotten more of a 3D look to it. Hitting N would reduce its height, H increases it. And if we look at wireframe mode by hitting W, you can see no additional geometry has been added, which is the entire idea behind parallax, that you can do these lighting transformations, texturing transformations within the GPU instead of the CPU. And so basically that is the project I made. The part that I struggled on most for this would be in actually displaying sort of the side edges that make up the more vertical portions of this parallax map. As you might see, actually, if I keep hitting H, all the layers, everything kind of breaks down into layers, and you sort of lose a lot of the simple, smooth surfaces that we had earlier. That is because, given that, let's say, a ray shooting from the camera has to, at some point, intersect with the surface, and we're trying to find this intersection point, the way we draw the ray is effectively a series of points along a line from which we sample. And since we can't just have an infinite number of samples, that's not possible, we have to sort of jump between each sample, which, as we can see here, can cause us to miss certain parts of our texture. And more specifically, it leads to some imprecision in the actual where exactly the intersection occurs. So when we're actually trying to sample through very steep areas, it might just miss the steep areas, and you then end up with a higher part of the surface and lower part of the surface just disjointed, just kind of floating away from apart from each other, which is not what we're looking for. So the solution to this is using oscillation, or what's called parallax oscillation mapping. It is a system where essentially we interpolate between the point that is effectively too far, which has already passed underneath the intersection point, and the point before the intersection point along our ray. And we do a simple interpolation between the two to find where the middle point is roughly and estimate where the intersection takes place. It's not perfect, but it certainly, as we can see here, proves to bring us the detail that we were missing with our previous method. And this also avoids us from having way too many samples within our rays that we're trying to shoot. That's my project. To just quickly go over the key points that I've got here. Scene graph was implemented with our parallax shader. We added normal mapping on top of it, and we played around with several different objects, such as this brick wall, to be able to view the 3D effect for different use cases, different objects in different scenarios. Thank you.